let's see an example where matters are just a little bit more complicated. Let's suppose we're trying to solve the system x equals 2y plus 1 and 4x minus 2y equals 18. All right, now again, our first equation is in the form x equals something. So we'll want to replace the x in the second equation by something in y from the first equation. But we need to be careful, because what are we multiplying by 4 here? We're multiplying x by 4. That means we're multiplying the entire 2y plus 1 by 4. So when we do the substitution, we should put this expression that's equal to x in parentheses. Whenever you do any sort of substitution, it's best to put what you're substituting in parentheses. Maybe you won't need them there. Maybe the parentheses will turn out not to do anything. But it's better to write them down and not need them than to not have them but need them. All right, let's see what we get. Here we're multiplying 4 by something with addition in it. We'll need the distributive property. 4 times 2y, that'll be 8y. 4 times 1 is 4. Let's simplify this a little bit, combine like terms. 8y minus 2y is 6y. Now we need to get rid of this 4. 6y equals 14. Divide both sides by 6. We'll get y equals 14/6. We might simplify that as 7/3. Now, who wants to try to read 7/3 off of a graph? That's right, nobody. This is the major reason that we are happy to have this technique for solving systems of equations. Sometimes our answers are fractions. The arithmetic isn't so bad. Reading them off a graph would be dreadful. All right, now we know y. Let's go back and find x. X is 2 times 7/3 plus 1. 2 times 7/3 will be 14/3. 1 is 3/3. Why did I do that? Because I need a common denominator. 14/3 plus 3/3 is 17/3. Again, we could also have used the calculator to do this arithmetic. Did that really work? Let's see. 4 times 17/3 minus 2 times 7/3. Let's see, 4 times 17 I am going to ask a calculator about off camera. This will be 68/3 minus 14/3. So that's 54/3. 54 divided by 3, that is indeed 18. All right, so that checks out. What was our solution? Y equals 7/3, x equals 17/3. It's important that we get these in the right order, right? It matters which one is x and which one is y. I'm going to give you one of these to try. I'm going to give you one where the numbers work out fairly nicely. Solve the system negative 5x plus 6y equals 3 and y equals 1/3 x minus 1. Pause the video and try this now. Well, again, we see this equation is in the form y equals something. So we're going to replace the y in this equation by this expression that y is equal to. Our equation will become negative 5x plus 6 times this expression that y is equal to, and we'll see that that equals 3. All right, again, we've just replaced y by this expression. What do we do now? Well, we have 6 times something with subtraction in it. So first we need the distributive property. We'll have negative 5x plus 6 times 1/3 x. 6 times 1/3, that's 6/3, so 2. 6 times negative 1 is negative 6. There we go. Okay, simplify this side by combining like terms. Negative 3x minus 6 equals 3. Get rid of the 6. Negative 3x equals 9. Divide both sides by negative 3. And we get x equals negative 3. How do we find y? We go to this equation. Y equals 1/3 times negative 3 minus 1. 1/3 times negative 3, that's negative 3/3, so that's just negative 1. We get y is negative 2. Did that work? Negative 5 times negative 3 plus 6 times negative 2 equals negative 5 times negative 3 is positive 15. 6 times negative 2 is negative 12. 15 plus negative 12, that's 15 minus 12, or 3, which is what we hoped we'd get. So yes, our solution is negative 3, comma, negative 2.